Good morning, friends. Today we will cover the most important part of the segment routing, that is the type of segment IDs. So this is just theory part. In-depth part I am going to cover in the configuration section. So in case if you don't understand here completely, don't worry. We will see in depth in the configuration section. So we have multiple segment IDs inside the segment routing. Few of them will be covered by IGP and few of them will be in the BGP side. Those are prefix-sid, adjacency-sid, binding-sid, anycast prefix-sids, and the same like BGP prefix-sid for the BGP prefixes, BGP anycast-sid for the BGP prefixes, and the BGP egress peer engineering for the BGP neighbors. So let's deep dive and let's understand one by one what are those exactly. And we have configured the segment routing on all the boxes. So on the R1 we have configured the prefix-sid absolute 16001. So you can configure the absolute value or you can configure it as an index. So in the case of index it will come here as a value 1. And once we configure the segment routing, then routers are going to advertise these values like your segment routing global blocks and the index value for this one into the routing IGP update, and those routers will receive those updates, and then based on that update he will going to calculate the label value to reach to that particular router. So router is going to figure out that 16001 label is for the R1 and the same label is going to push in the MPLS forwarding table. So this is we called as a prefix-sid. We assigned it to the loopback interface of the each router. This is manual task, but adjacency-sid will be allocated by the router, that is by default. So we can see this snippet here. This is for the IPv4 and IPv6, this global range. So we can see that sRGB value is the 16,000 and total range is 8,000, means from 16,000 to 23,999. This is the update for the router 1. If you see, this prefix is 1111/32 and node seed bit will be set for this one. So in the case of prefix-sid, node seed will be set, means we can say this either prefix-sid or we can call it as a node seed as well. So if you see here, it is prefix-sid. But in case of anycast, which we are going to cover in the next slides, node seed will be set as 0 because that is the anycast-sid we use for the group of nodes, not for the single node. So for the single node we need to set it node seed as a 1, and here we can see that index value is advertised by the router 1, that is value is 1. So if you 16,000 plus 1, that is 16,001, that's become the label value for the 1.1.1.1/32 prefix that we called is as a prefix-sid. Next one is adjacency-sid. So adjacency-sid will be allocated by router by default, no need to assign it anywhere, and it's by default it start from the 224K, and it will be assigned to the particular agency. So it could be ISIS or OSPF agency, and it will be assigned by the both way. So R1 will assign his own agency seat towards R2, and R2 will assign his own agency towards the R1, and this is the local significance. Means scenario could be there that this router will assign the same agency seed towards this, because this is the locally. So let's say for this particular interface R1 has assigned this adjacency seed, and we have one more interface, there it will assign, let's say 24002, the next value or any particular value within that range. And when your packet hits to the R1 which is going via this particular interface, if router needs to route this packet via this interface, besides this shortest path, then he will see that okay, this particular label belongs to this particular interface. Based on that one, he will forward on this interface. So under the adjacency-sid, we have many types. Like for the L1 and L2 ISIS agency, that is for IPv4. Again we have for IPv6 L1 and L2. Then for OSPF we have IPv4, IPv6, LAN adjacency segment ID for the broadcast segment. So if we see the figure here, under all these connect P3, P2 and P1 are connected in the local LAN. So they will assign the adjacency seat for that particular neighborship between this within this local area network. We have layer 2 adjacency segment IDs. So this segment ID we use in the case of bundle scenario. So where we need to push the traffic over the particular member link. So let's say we need to route the traffic over this first link. Then hidden will push this particular label on the IP packet, so that traffic should go via this particular member link. And for all agencies we have the protection eligible and protection not eligible segment IDs as well. So protection eligible means for which we have the backup path or for which we have enabled the TILFA. This is just snippet for the level 2 IPv4 and IPv6 LAN adjacency seed. We can see here it is LAN adjacency seed for the IPv4. So this is for protection not eligible, locally significance, and this is the adjacency seed label value between R1 and R2. Same is for the IPv6. It's a locally significance, yes, adjacency is locally significance, and this is the label value assigned for the IPv6 adjacency seed. So we can see this is LAN adjacency seed. Next we will see what is the binding segment ID. So name itself is suggesting that it binds between two things. So first, when we configure the SR policy on your box, so SR policy configuration we will see in the subsequent sessions. So once you configure the SR policy, so you have two options: either you can define it manually, binding sid, either you can define it manually or the router will assign it automatically. So in that case, prefix will point towards that particular binding sid and it will point towards the sid list. So in case scenario may be there that you don't have binding sid, then in that case policy will not come up. So let's say we have configured the SR policy for the hop 5.5.5.5 and we have defined the binding sid as 1000. So what will happen, that prefix 5.5.5 so in this software program it will point towards the binding sid 1000 and then it will point towards the segment ID list which is available for this particular policy. So this is for the local steering, but we have use case in the remote steering as well, and it has many advantages. So when packet arrives on the head end with the segment out ID, that binding segment ID acting as an active segment, so it helps to steer the traffic either in the SR policy or SRTE associated with that segment ID. So it helps to reduce the number of segment list. It isolates one domain from the instability of the another domain, and no need to share the information between one domain to another domain. So let us see with the help of this diagram. Let's say for this policy which is going towards PE7, we have configured binding sid as 1000. And this SR policy is going via this path. So this is the sid list. So once SRPC calculate that path and he sends to P1, he will push that binding sid on top of that packet, and once that packet reach to P3, he will remove that binding sid and he will push all these three labels on top of that one. So we can see that it's reducing the number of segment list. So in this scenario, between this point we have carried only one segment, and here it is expanding into 3 segment list. So here we have configured the binding sid as 1000. So whatever changes happen in this side domain 2, whether this label gets changed, this label gets changed, whatever maybe changes are there, those are not reflecting into the domain 1, because our binding, as long as the SR policy is active, binding sid is active, then this policy is up and we can push the traffic over towards the remote PE7. As we are using that binding sid here, we don't need any information to propagate from domain 2 to 1. We just need the binding sid information here with the help of SRPCE. One more use case is SRT to RSVPT interworking. So let's see, I have two domain, one is the SR routing domain and another one is the RSVPT domain. So in that case, in this domain I have configured the RSVPT, and for that RSVPT I have configured binding seed as 1000. So with the help of SRPC, PE1 will push those binding seed on top of that packet. So once it receives on the PE3, that is, we can say that ABR or ASBR, so he will swap that binding seed with the RSVP tunnel label. So this way we can configure the binding seed under the RSVP tunnel, which can help us in the interworking scenario. Anycast segment ID. So if you remember the multicast and how anycast work in the multicast scenario, then it's easy to correlate that with anycast segment ID. This anycast segment ID, we assign it to the group of nodes, not the single node. Hence we need to set that node flag off here, and then traffic will be route to any nearest P router or any group of nodes based on the anycast seed. So let's say P1, for P1 PE5 is the nearest point, so he will route it any traffic towards the PE5. For PE2 PE6 the near one, so he will forward that traffic towards the PE6 based on this label value, anycast seed value. But let's say PE5 is down, then based on the label value, traffic will be rerouted via the PE6. So we can see here we are achieving here high availability scenario. So you may be wondering that even in the general case, if it is multi-homing and if R5 goes down, then obviously traffic will go via the PE6. But in that scenario, all the routers need to run the SPF and then they need to figure out the path. But here already we have the anycast-sid available with us. Based on that one, router is going to push the traffic towards the PE6, that is the nearest node, after PE5 went down. This is just snippet for that anycast prefix. So let's say we have configured 56.56.56.56. This is the prefix-sid. You should note it here. This is also prefix-sid with node bit set as a 0. So as we saw in earlier configuration, here we need to clear that node flag because this is for the group of router, not for the single router. And this is the value index value for that anycast-sid. So this is the hex value. If you convert it to the decimal, it will come as the 56, which we configured as the index value. Last but not least, BGP segment ID. Prefix segment. So it is same as the IGP prefix segment. This will associate it with the BGP prefixes. So whatever BGP will advertise those prefixes, so these segment IDs will attach to those BGP prefixes. Then anycast segment ID, same for more than one node or means group of nodes, those who are advertising the same prefix segment IDs to achieve the load balancing or high availability, same as what we saw earlier for the IGP case. BGP peering segment. This is for the specific BGP neighbors. So under this one we have multiple segment IDs. One is for BGP peer node associated with particular BGP neighbor, either it could be external or internal. Then peer agency segment ID associated with the specific underlying path or link towards the specific group of neighbors. And then last but not least, it is BGP peer segment ID, that is for the peer group. I hope you got the glimpse of segment routing. What are the segment IDs? How many types are there and what are they? And what is their function? In depth we are going to cover in the configuration section as well. So stay tuned for the more information. Thank you very much.